Day 5. Advent of Code. Sorry, Advent of Bash. If you give a seed of fertilizer, you take the boat, find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source? Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water for a few days, weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help us with our food production problem. The latest Island Almanac just arrived, and we're having trouble making sense of it. The almanac lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer to use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but numbers are reused in each category. That is, soil 1, 2, 3 and fertilizer 1, 2, 3 aren't necessarily related to each other. The almanac starts by listing which seeds need to be planted. 79, 14, 55, and 13. Okay, so this is saying 50 and 51 map to 98 and 99. All right, not so bad, not so bad. Using these maps, find the lowest location number that corresponds to any of the initial seeds. So we just go through a bunch of translation layers. It's effectively the same thing, just repeated a number of times. And then at the end, we'll get a location. Let's make a parse function. And we're gonna read one line off the top and then echo it, and that's our whole program. We can do parse sample.txt. Get the first line. All right, here's our numbers. And then I guess we'll replace the spaces with new lines to get a nice nice list. We can say seeds is this. What do we need to parse next? These big chunks. That gets rid of all the new lines. If we want to only get rid of double new lines, we can do this. And now what we can do is we can replace these with some symbol, like an @ symbol. And now we can get rid of single new lines, replace them with a bar. And then what we do is we bring back the double new line. So we say, get rid of the @ symbol, but let's just do one new line. Yeah. So now each line is one of the things, kind of. We might need to do a read first to make that a little better. We're gonna do a grep. We're gonna do this. Oh, now that output is looking good. We gotta figure out what to do about these ranges. We're gonna do another sed because we're adults and we're allowed to have a few seds. We're gonna find a 0 to 9 space, a few of these. I think we're gonna end up writing the most horrifying set of all time. Seems like what's happening here. All right, let's start with some parentheses. It's good to have parentheses. So let's make some token, like the seed number goes here. It's an @ symbol. If @ is greater than source range start, which is the second number, so 2, if it's greater than or equal to that, and it's less than 2 plus 3. This is getting complicated fast. Let's get rid of these spaces to make it a little more readable. There we go. Now it's making sense. So that tells us whether or not it's in the range, right? Now we can multiply by our conversion. So @ minus the source range start plus 1 is the conversion. And we should be looking good. The one thing we have to handle is when it's not in the range, when it's not in any range. I think we're going to have to do that in a post-processing step, unfortunately. But this is looking good. We're going to replace the bars with plus signs. And yeah, that's our little thing. And let's agree to never touch that again, because that looks pretty awful. So we need to run our seeds through it. Let's just say 69 for now. Okay, so we can put a number into it. Now we need an outer loop. Okay, we're pumping all of our seeds through the translator, which should give us a number. We can do some new lines there. What are we supposed to get? 82, 43, 86, 35. Great. Then we need the lowest one, right? So we just get rid of this. We get rid of this. We just have these numbers. We need the lowest one. So we go sort n, head 1. There we go. 35. Input. Okay, that's a different number. And we get the right answer. Bash will never steer us wrong. All right, excellent. Let's go to part 2. Everyone will starve if you only plant such a small number of seeds. Rereading the almanac, it looks like the seeds line actually describes ranges of seed numbers. Oh dear. The values on the initial seeds line come in pairs. Within each pair, the first value is the start of the range, and the second value is the length of the range. So in the first line of the example above, 7914, this line describes 2 ranges of seed numbers to be planted in the garden. The first range with seed number 79 contains 14 values. Now, rather than considering 4 seed numbers, you need to consider a total of 27 seed numbers. Let me look at my input real quick. Are you kidding me with these numbers? Excuse me? I don't think Bash will survive if I rip that many numbers through it. Like what is this number? It's like 235 million? I think we have to be more clever to get this. I don't think we can brute force this in this language. Fuck, I hate being clever. What if we do it? What if we walk backwards and we do like a search algorithm through like these steps? So we sort this, and then I think the ranges on these are big too though. So it doesn't really help. It's like you have to find like the intersection of these ranges. So we want to identify that 56 is the smaller number. So we're going to take 93 and map it to, oh, fuck. No, it gets weird when it doesn't map onto 1. So we almost need to like add another level to this. That's like, so then we go through that one. Then we chain this 93 over to, I think it's this one. And then we have to look over where the 45 goes. This one. So is this not that bad? Maybe this is not that bad. But it's not just the start of the range, right? We need to find all of the ones that intersect. Because like this one's quite a big range. It goes from 25 to 95. So it technically overlaps all 3 of these. It's almost like a tree problem, because we're gonna walk our way up the chain. We're gonna get back to the seed ranges, and in theory, we'll have 2 cases, right? The first one is we get to the top and there's no matches. If there's no matches, then we go back to the start and we pick this one instead. The second case, there are matches. And we just have to find the smallest seed number. It's just the first number. It's the first number that overlaps. Okay, I think we need to come up with a method for determining like the intersection of ranges. Okay, let's think of all the different cases that can happen between two ranges, right? Say we have a red and a blue one. So one case is they're the same. Well, that's a bit of an edge case. One case is that the red one is bigger than the blue one. One case is that the blue one is bigger than the red one. There's also a case where they're offset like this. There's also a case where they're offset like this. And the last case is they are not even fucking close. So there's 6 different cases. I guess one thing to consider is you could have like where there's a little hole here. This would be annoying because that would map to the same number. This seems hard to code. We know it has to fit into this bucket coming from the previous one. What that means is that we can modify this red range and cut it in half. So our search space is bounded. I think this can work, but I really don't want to code it in Bash. That's the problem I'm facing right now. Okay. So these are our ranges, which we can pipe into tack to flip over. Tack is of course, the opposite of cat, because we want our tree we want it to be a, top to bottom sort of search. Bottom to top is weird. And we can pipe into sort map, which is going to be a function that I'm going to make right now. I want it to replace these with these, and then I want it to sort n. What happens? All right, my tree is sorted. Now I just need to traverse it. Great. We find the intersection of two ranges. Either the red range starts inside of the blue range, or the blue range starts inside of the red range. If neither of them start within each other, then I think it's easier to write it in code. Okay. So it's like we thought. There's no interaction or intersection between those two levels. Okay, so look how cool this is. We've calculated the intersection of our ranges. We have a problem though. I need to find the holes in my range. I don't know how to do that. I need to figure out how to detect this little jerk. Okay, we're paving the road. We're doing the thing in the picture. We've solved the question mark. No problem. The next step is scary because it's gonna reveal the problems with this approach. There we go. We got our seed ranges. Basically what's going on here is I don't know. Something to do with there's the ranges and then you make like a tree. But then yeah. So oh. Oh, this is tricky. This is good sample input. I know why it's broken. So, in the above example, the lowest location number can be obtained from seed 82, which corresponds to soil 84, fertilizer 84, water 84, light 77, temperature 45, humidity 46, and location 46. Now, let's review. Our ranges for humidity to location start at 56 and 60. Notice that neither of these ranges include 46, which means there's a whole range of numbers that we're not considering from 0 to 56. And we need to add that range. We need to do the same hole filling algorithm that we did for all of the other ranges to this very first one. We have a path forward. So how does this paving shit work again? Yeah, we have a pointer. We go over the only gonna do this to the last level of the tree. Just kidding, the first level of the tree, because we already attacked it at this point. If I equals 0. Oh boy, it's fun time. Oh boy. So, what do we do if it's fun time? We echo level tr. Great. These are our ranges. We're just gonna call it fun. Echo the fun. Okay. Local read fun. What fun? And then we'll do pointer equals. Okay. Also make pointer local. AD plus AL. Okay. And let's see what fun wants. We're having so much fun. I'm running out of variable names, so we're just gonna call this one. Okay, wait, where were we having fun? Right here. This is the fun. 55. That's not right. Oh no. No. It did say 82 down here. Yeah, 82 is the seed number. Let's just try. Let's try this on input and see if it even completes. Oh, it was pretty slow, but it did complete. Okay. Let's see if part 1 can save us. No, so we do seeds, paste, paste. I don't think this is right, but I'm gonna send it. Oh my fucking What? The fuck? Well, yeah, I meant to do that. That was I don't know. They just make these too easy. I think it's just a little bit too easy for me. That's all.